Hey, hi friends, very good morning to everyone. So, today, before we start off with the remaining theoretical portions, so first we will start with Linux installation and let it continue so that by the time we complete our theory portion, like this machine will be ready for us for Oracle installation. So, uh, the steps would be pretty same. Only in some situation where we need to create the mount points, it would be different. So we just need to go and click on new virtual machine. Then select the software here, the ISO file which you would be downloading. So the one which I have selected is Oracle Linux 7.4 64-bit version here. And then choose the location where you want to have this. And it would be better if we have an 80 GB of space, so that would be enough for our Oracle installation. So here I am taking 80 GB, and it is up to your wish whether you want to store it as a multiple files or whether you want to store it as a single file. So better to store it as a single file so that while deletion also it would be pretty much easy in case if you want to delete this virtual machine in future. Then you can customize your hardware. So here especially like memory, let's say I'm going with 2 GB memory. Then the important thing here is network adapter. So network adapter you can choose as bridged networking. So by default NAT will be selected. So it is better to go with bridged connection. These are the two changes. One is RAM. In case if you have a better RAM size like 8 GB, you can increase your RAM size. And especially the other changes about this network adapter, make sure it is going with bridged connection. So once you have made those changes, just click on finish. It will start the installation. Here you can click on I finished installing. Otherwise that pop-up message will keep on coming. And go with the first option, that is installing the Oracle Linux 7.4 version. So choose the option whatever you want. So I'm selecting English of India. And this is the screen where we are going to provide all the details. So the first thing that you need to do is software selection. So here you can see it is going with minimum installation. That may not be sufficient for a Oracle installation later. So we need to go with the last option, that is survive with GUI. And on the right hand side you need to select all the options except the one which says database server. So you will see something like this one, Maria database server. So this is not required. And then MySQL database server, this is also not required. Then PostgreSQL database server, that is also not required. So I just deselected only those three. Whichever is saying database server, I just deselected those options, and I selected rest of the all options and just click on done. So just wait for a few seconds till that triangle mark is gone. Yeah, now it is done. Now we need to go ahead with partitioning. So when it comes to partitioning, you you need to scroll down and you need to select the option I will configure partitioning here. So instead of automatically doing that, we are going to divide the disk. Then click on done. It will take you to a screen like this. So here you can select standard partitioning and click on this plus symbol. Then it will ask you to choose the mount points. So the first mount point is root. So you can give 15 or 20 GB to that. 15 GB is also fine. Or let me give 20 GB. Then you have a swap mount point. So here, if you scroll down here, you can see swap, and swap is generally expected to be double the size of RAM. So I selected 2 GB as my RAM size. So 2 into 2, 4 GB should be the ideal value for swap. So because I have space, I'm just giving extra. So I'm giving 5 GB over here. Then your regular mount points like U01, you can go with 20 GB. Then U02, again I'm going with 20 GB. And last and final U03, I'm going with 15 GB. So filling up all the entire 80 GB of space here. So root file system 20 GB, swap 5 GB, then U01 and U02 20 GB, and finally U03 15 GB. So this is what the partitioning that we need to do. So once we are done with this, click on done on the left hand top side and click on this accept changes. Then comes the important thing, that is network and host name. So just click on that network and host name and go to configure. And here you can go to IPv4 settings, and here instead of automatic you go with manual method, and then you need to add the IP address over here. So how we are going to add the things, like what is the IP address, what is the net mask and gateway. Open your Windows command prompt and type ipconfig. So if you are using a direct LAN cable, you will see something like Ethernet adapter Ethernet, or if you are using a Wi-Fi network, here you will see wireless connection or wireless adapter. So whatever you are choosing with, take that particular connection details. So what you need to do is, for the IP address, here you are seeing some series 192.168.1. So here you are seeing a series 192.168.1.128. So in Linux machine, you need to give the same series like 192.168 1 dot. So give some different number. Like here in Windows, you are seeing it as 128 as the last three numbers. Maybe here you can give something like 130 or 129. Your wish. So that is how you need to give the IP address. Then subnet, net mask, and gateway values should remain same. So whatever the net mask value you are seeing here, as it is, you need to give there, and whatever the default gateway you are seeing here, you need to give the same thing over there. So I'm just changing this to 55. Sorry, 0, then 192.168.1.1. So DNS servers and all not required, so you can leave that as is. So once you have done these changes, one more thing is go to general and click the first option. Automatically connect to this network when it is available. Otherwise what happens is every time when you start your VMware machine, a network will not come up automatically. So select that first option, automatically connect to this network when it is available, and make sure this IPv4 settings, the IP address whatever you have given is okay. Then click on this save button at the bottom. So the moment you do that, it will highlight that IP addresses over here. So the same IP address what you have given will be highlighted here, and then subnet mask and the default gateway value. Then coming to the next one, at the bottom you can see the host name. So you can choose whatever the host name you want. So let's say I want to be as 12c server. So I will give the name like that, 12c server, and click on apply. So these are the two changes that you need to do. So once you are done with that, click on done, which is on the top left hand side, and that's it. You can just click on begin installation and set your root password. So if you are choosing a weak password for root, then it is you need to double click on this done 2 times. Then meanwhile it is going for the installation process. So is that clear with everyone?
Yes.
Okay, so let's go with the theory portion. Meanwhile this installation completes. So coming back to the architecture. So till now whatever we have seen is 10G architecture and its components. Now we need to look at the 11G architecture. So what is the difference that you have seen in this diagram?
Result cache.
Exactly. So the only difference that you will be seeing between 10G and 11G architecture is this result cache. So this is the extra component what Oracle has introduced in 11G. So now what is this result cache and how it is going to work? So to understand about that, we need to know about the select statement processing. So when we see the select statement processing, then easily we will understand what is this result cache. So let us go and see that. So user process issued the statement. So things will be same, just like the 10G architecture. So user process will issue the statement. Server process will send the statement to library cache. So because now we have result cache also in shadeful, so I just added that component as well. So in library cache, parsing will take place. Optimizer will generate the best plan. Then the statement will come here. It will get executed here, and server process will search for the data in the LRU list. So if the data, so I'm talking about the very first time the query is issued. So as I said, the very first time the query is issued. So let's assume data is not available in the LRU list. So server process will come down to database. It will search for the data and it will place the data in the top portion of the LRU list. And depends on filtering or non-filtering, the data will be given to the user process. Now, till here, as it is, it is 10G's architecture. Now, in 11G, what happens is, especially if you are using result cache, whatever the data that you have given to the user, that data means the rows, data in the sense, whatever the rows that you have given to the user, that rows, plus the execution plan ID. Every execution plan will have a ID. So that execution plan ID plus the rows which you have given to the user. So those two things will be stored in the result cache. So what Oracle will do, it will take the execution plan ID from the library cache, and also whatever the data that you are giving to the user process, the copy of the data, both combined together, it will store this in result cache. Now what is the advantage here? If I store in result cache, what is the advantage? Assume another user came into picture and that user also issued the select query on the same table. So what the server process will do? Server process will send the statement to library cache, but already parsing is done in library cache, and even the optimizer generated the execution plan also. So then this server process, by taking that execution plan ID, it will come down to result cache. From library cache, server process will come to result cache. And in result cache, it will verify whether the same plan ID is existing or not. Suppose in library cache, it got the plan ID as 1234. So when it comes to result cache, in result cache, it will check, sorry. So do I have the plan ID with 1234 or not? Suppose yes, the plan ID is available. Then as I said, along with the plan ID, the data also will be available. So what server process will do? Directly it will give the data from result cache to the user. So it will just whatever the data that is available in the result cache, it will give directly that data to the user, which means here server process is not performing execution, it is not performing parsing, and even it is not performing fetching also, because you are not reading the data from the LRU list. So almost everything is being done in shade pool itself. Parsing is happening in the shade pool, and then execution is not happening at all. Why? Because the data is readily available in the result cache. So fetching is also happening from the shade pool itself, that is from the result cache. So because of this, the data retrieval will be a bit faster when compared to uh, the other one, like the 10G architecture. So that is how result cache is going to help you in getting the things done. So is that clear? What is the role of result cache? Okay. So now we will be having so many questions like how much data result cache can store, because there will be thousands of users connecting to the database. So if for every user result cache wants to store the data, means how big the result cache should be. So first the size of the result cache. And next question could be, suppose if I modify some data, like for example, user 1 issued one select statement, the data was stored in result cache. User 2 issued some update statement, and then on the same table, and then user 3 issued a select statement again on the same table. So obviously, because the data got modified by user 2, whatever the data that user 3 is seeing should not be the old data from the result cache. So Oracle will take care of this internally. Whenever the data got modified, the corresponding result cache data will be marked as invalid. So if the data got modified, the corresponding data will be marked as invalid. So that intelligence Oracle will take care of this internally. So let us look at those things. So as I said, result cache is the new component that got introduced in 11G, and it will store the execution plan ID and the corresponding rows. So how we are going to enable result cache? So we have a parameter. We can specify that in either P file or SP file. So the parameter name is result underscore cache underscore mode. So there are two possible values for this. One is manual, or second one is force. So when you say force, for each and every select statement in the database, it will use result cache. Means you are forcing each and every statement to use result cache. But if you say manual, you will be deciding, you in the sense the person who is writing the SQL query will decide which statements should use result cache and which statements should not use result cache, and how they will specify. Suppose I decided that one particular statement wants to go with result cache, how I will be specifying that with the help of something called Oracle hint. So while we write the SQL queries, we have an option to provide a hint. So we will discuss more about hints in performance tuning. But as of now, for suppose it will be written like this. So if I go with some select statement, it will be written like this. So we just need to keep this particular clause in our select statement. Then while processing, Oracle optimizer will understand that these particular statements want to use result cache. So we can just specify in such way if we are going with a manual method. So because in 10G we are using automatic shared memory management. So and the result cache is part of shared pool. So this ASMM itself will take the size of the automating the size of result cache. But no, I want to give an exclusive size to result cache. Yes, we have a value for that as well. So you need to decide, how much size that you want to go with, and then you can specify the size for this parameter. So the main important point is this: Oracle is recommending to enable the result cache only if the database is hitting with a lot of frequently repeated statements. The same statement is repeating every time. Especially this happens in OLTP environment. So for such kind of statements, Oracle is recommending to enable result cache. But otherwise, it is better to not use result cache for OLAP or data warehouse environments where the queries will be changing each and every time. Also, as I said, the last point, whenever any DML or DDL statements are performed and your data got changed, then the data in the result cache will become invalid, and you need to reprocess the again. So these are the things about result cache. So anyone having any questions?
How much size can we specify here?
Depends on your RAM size. So same thing, like if you have enough RAM size, then you can go with a bigger value. And also depends on for how many queries you are going to enable the result cache. Suppose you want to use for entire database, then obviously the size should be very large. And also one more thing is, because this result cache is part of shared pool, and shared pool follows LRU algorithm, which means the old data whatever is there, it will be flushed out whenever the space is not sufficient. So that thing we need to remember. So we cannot expect the data in the result cache will be there permanently. Suppose already your result cache is full and I am copying some new data, then old data in the result cache will be flushed out in order to accommodate the space. So is that clear? Any questions? Okay, so let's move on to the next topic. So in 10G, I told you that all the SGA components except log buffer cache size will be managed by a single parameter SGA underscore target. And for PGA, we have another parameter PGA underscore aggregate underscore target. So still in 10G, it is, not a difficult thing, but people feel like how much we need to give to SGA and how much we need to give to PGA. So that kind of confusion is still there in the DBAs. So handling or taking it to the next level, Oracle has introduced a new concept called automatic memory management. So with this automatic memory management, Oracle is going to say that you don't need to worry about the SGA and PGA sizes. Just declare one particular parameter, that is memory underscore target, and I will take care of both the SGA and PGA memory management. So which means that it is going to decide whether you mean to say how much value that it need to give to SGA and how much value it need to give to PGA. So purely it is there now with Oracle automation. So that is about this automatic memory management. So for example, I have a 8 GB RAM, and in that 2 GB was taken over by OS. I have left out with 6 GB. So if you just say memory target is equals to 6 GB, internally Oracle will decide how much value out of 6 GB, how much it need to give to SGA and how much it need to give to PGA, and whenever the memory management is required, like SGA need to allocate more size or PGA need to allocate more size, then Oracle will take care of those things internally. So that is about this memory management. So just like how we have SGA max size, here also to define the maximum size for memory target, we have a parameter memory max target. So that is a static parameter, whereas memory target is a dynamic parameter. Now the biggest relief also what we have, even we have this in 10G also, but a bit enhanced version is now if I give some value to my memory target to manage both SGA and PGA, how I would know whether I am over allocating the memory or under allocating the memory, or is my memory size is sufficient or not for Oracle. So I have given 4 GB. So how I would know whether 4 GB would be a good value or 4 GB would be a bad value for my memory. So really we don't have any specific calculation or specific formula for that. How much SGA value we need to give, we don't have any formula, or how much PJ value we have, we don't have any formula. So the only way that we can do is we will be allocating some size initially when we are creating the database, and after maybe let's say 1 month, we will be running a query against a view called $memory target advice. So this view will tell you, it is going to give you the advice based on last 1 month analyzation. It will tell you so based on a last 1 month analyzation, so it is it is going to tell you whether the memory whatever you have allocated before 1 month is sufficient or not. So during the time of performance tuning, I will show you this and I will tell you how we need to do that. So, but as of now, you can remember we have such view. So even when you go to real time, when you enter into a project, suppose you are getting performance issues, you can, if you suspect that it is because of memory allocation, you can check this particular view to see whether the memory that was allocated is sufficient or not. So this is one good enhancement or one good utility what we have as a DBA. And this table tells you the evaluation of the parameters over the versions. Like if you take Oracle 8i, for PGA we use it to set the first 4 parameters, and for SGA we use it to set the last 5 parameters. So this has been enhanced in 9i by automating PGA. So in 9i we need to declare only one parameter for PGA, and Oracle will take care of that internally, but SGA continued as it is. But in 10G, SGA is also automated, And going with 11G or 12C, both SGA and PGA is automated. But still, if you look at the table, log buffer parameter is still not automated because it is a static parameter. So is that clear? Any questions? Okay. So let's go with the next thing, that is the new 12C feature. So 12C introduced a new memory component again, so which we call it as in-memory column store. So especially this component is introduced because of the to give benefit for the data warehouse environments. Like how result cache is to give benefit for the OLTP environments. This in-memory column store is to give the benefit for the OLAP environments or the data warehousing environments. So what will happen? Like what is this in-memory column stories? Generally, if you copy the data as we see in this picture, if we copy the data from the database to LRU list, the data is getting copied in the form of blocks, and inside a block we will be having rows. We know that already. But here in 12C, column store, in-memory column store, what it will do is it is going to have a separate memory component. Like you have database for cache, you have another component called in-memory column store, and the data will be copied into this particular memory area in the form of columns, not in the form of rows. So let me take this picture in a bigger size. So if you look at this diagram from the disk, suppose there is a schema called sh. So in sh schema we have three tables: product, customers and sales. So generally what happens if you are copying this data to buffer cache, which is the regular way here, so you will be seeing that data will be copied in the form of blocks. But on the right hand side, if you look at, we are using in-memory column store. So the data is coming in the form of blocks. For example, product table and its columns, customer table and its columns, sales table and its column. So instead of storing the data in the form of block, now it is going to store the data in the form of these columns. So what is the advantage by doing that? The advantage is to quickly form the report. Like in data warehouse environments, mostly we'll be generating the reports. So to generate the reports, always you will be selecting the column values. So that is the reason. If you have your data in the column format, building or structuring up that particular report is pretty much easy and faster. So for that particular reason, Oracle has introduced this in-memory column store. So at least in my experience, I have not seen people still using this because 12C itself is, people are moving to 12C slowly. So still this parameter is not, being used in real time. So the size is defined by a parameter called in-memory underscore size. So in 12C release 1, this parameter is static. So if you want to change the value, then you need to go ahead and restart the database. But from 12C release 2 onwards, Oracle has made it as dynamic. and also how we are going to store which columns, I mean, which table should go to in memory and which table should not go to in memory. We have, okay, so it's not there. So we have, while creating the table itself, we can go ahead and we can declare it. For example, we can say create table T1. You need to specify the columns, and at last you need to say in memory. So just if you give this clause, then Oracle will understand that you want to have this table in in memory, or existing table also you can alter it by saying alter table name and storage in memory.
Okay. Pawan, can you repeat again what is in memory here?
Uh, this one in memory column store.
Yeah. Yeah, can you please again repeat this in
Okay.
memory concept?
Yeah. So in memory column store is the new component introduced in Oracle 12c. So just like your database buffer cache, you will be having a separate component called in-memory column store, as you are seeing in the diagram. So normally what happens is when you are selecting some data and putting the data in the database buffer cache, it will be stored in the form of blocks. And blocks is nothing but rows. So inside block we'll be having rows. But when you are copying the same data to in-memory column store, then the data will be stored in the form of columns. Suppose your employee table is having 5 columns. So as this, those 5 columns will be kept in the in-memory column store. So the data will be there, so in column wise. So here you are seeing, vertical bars are there, white color vertical bars. So each and every white color vertical bar represents the column inside that particular table. So if your employee table is having 5 columns, then those 5 columns will be represented or will be copied into this in-memory column store. So what is the advantage is if you run select star from EMP, then obviously it means that you want to retrieve all the column data. Then quickly Oracle can just combine all these 5 columns and it will give you the data directly. Or otherwise, if you are using database buffer cache, it need to pick up all the blocks, it need to then sort the data, and then it need to give it. So that kind of lagging is disabled. I mean, it is bypassed now.
Okay, so this in memory, okay, when you talk about this won't be stored in the database buffer cache. So
No, it
if
is a separate component.
memory component.
Yeah, it is not a. It is not part of any existing memory component. It is a altogether new memory component.
Oh, okay, it's altogether okay. So when you say select star from EMP, I'm just giving an example. Select employee number from EMP. So then what will happen? You're saying the whole column data. It will just store the whole column data, right? Not the rows. Now just the column data into that component, memory component. Correct?
Yes, exactly.
Okay. Okay.
This uses any algorithm in this?
Sorry.
Algorithm, it uses any like algorithm LRU list and MRU in this part.
No, we don't
In
have anything like that. Only thing is it follows. Okay, you mean to say like again how the data will be managed, right?
this
Yeah, so data will be managed again the same way, like LRU algorithm itself. So the more data that we come in, the old data will be flushed out.
do we need to specify for this also a memory size on this?
Yes, of course. That is where we have this parameter in the third point. So we need to declare the
So
size.
Yeah, one more question is like, suppose if you declare a table, right? While creation of the table, you said, right, you have to declare in memory, correct?
Right.
So only those tables you can utilize this feature, correct?
Exactly.
Okay, there is no hint, nothing like that, but at the table level definition, you have to define that, and then only you can make use of it.
Yes. Right.
Okay.
So here it is mentioned only the objects specified as in memory in its DDL will be stored in memory, and also we can change the priority, like while if you want to compulsory have one table in memory, then you can set the priority as critical. So here itself we can say in memory priority critical. So then it is like the data, the table data will be there in memory compulsory, which means until unless very much required, Oracle will not apply LRU algorithm on that. Means the data of that particular table will not be flushed out from the in-memory column store. Or if you specify it as a priority low, then the data will may get flushed out faster than other tables. Like suppose you have three tables, one is declared as critical, one is declared as medium, and the third one is declared as low. So let's assume all these three are occupying entire space in memory. When you try to copy the fourth table data, then obviously Oracle will check whichever is copied with low priority. So that table data will be flushed out first. So if you want, we can go with this priority as well, or otherwise by default all will go with low priority. And also
So one more question here. So whenever you define as in memory, it will never use the database buffer cache.
no, it will not use. Until
Okay.
unless you disable that, it will not use.
It will not use it.
And also, in-memory column store can be enabled at column, table, materialized view, table space, or partition levels. Suppose you don't want entire table to be there, but you want specific columns inside one table to be there in-memory, you can specify that one as well. Suppose like C1 and its data type, then you can say in-memory, and then C2, then its data type, like this. So here what happens is, because you have not specified anything with respect to C2, so C2 data will go to database buffer cache, C1 data will go to in-memory column store, because here you declared for only one particular column. The same clause if you keep at the last, then it will be applicable for table level. So like this, either you can go with a single column or multiple columns, or you can go for a full table, or you can declare it at table space level also. So while creating the table space, if you specify this particular parameter, and inside the table space you have suppose some 10-15 tables, and those all 10-15 tables will go to in memory automatically. Or we have something called partition tables. So even we can apply that at that partition table level as well. So this is what exactly the use of in-memory column store. So especially as I said, it is applicable for OLAP environments, and you're going to construct some reports from the large tables. Then it is better to go and initialize this in-memory column store feature. So now one thing is, there is no change in DML processing when you are using in-memory column store. Like how the DML processing used to be done earlier, the same way it will follow as it is. Means it will use database buffer cache and it will use write list. So we don't have any specific write list kind of thing in in-memory column store. In-memory column store is only to read the data. So writing and all, or the changes and all will happen in the write list itself. And also you can see this point, in-memory column store is not applicable for sys user and system or sysaux table spaces. So for that, for base tables and all, you should follow the regular database buffer cache thing. So there is a separate process introduced for this whenever it is performing the activity. So we call that as a worker process, which is represented with WNN symbol. And you can have multiple processes as well, like you can have parallel processes by just specifying this parameter in memory max populate servers equals to 10 for suppose. Then 10 processes will be there and they are going to work. They are going to copy the data from database to this in-memory column store faster. But there is the thing is by default the count, this the number of worker process will be one half of your CPU count. So if your CPU count is let's say 64, then one half, that is 32 worker process you can have it. So more worker process results in faster data population, but they use more CPU resources. Because in-memory component, because this in-memory column store is a memory component, obviously like any other memory component, once you restart the database, nothing will be there and the data need to be processed again. So that is the new component what we have in 12C architecture. So any more questions from anyone?
Pawan, for example, now one person has issued a select star from employee, and after 2 to 3 minutes, another user has given the same statement. So how this memory will be column will be retrieved and it will be stored and it will be retrieved, or it will be again from the IO, it will take from the disk and it will be given to the data to the column.
Depends on what happens in those 3 minutes. Suppose in those 3 minutes the data was not flushed out from in-memory column store, then yes, the data will be picked again by the second user also. The data will be picked from the memory itself. But let's say in these 3 minutes, some other users copied more data, which made the data what first user has issued flushed out from memory. Then yes, second user also need to perform an IO and need to copy the data again.
You mean to say, like, if it is available in the memory store, then only we can take the details, or else it will go from the disk itself?
Yes, exactly.
Oh.
So then we have some new background process in 12C. So one is cleanup main process. So generally we know that Pmon is going to clean the orphan process. It will release the logs, etc., etc. So to help Pmon, now we have this new background process CLMN. So as you can see, it is responsible for cleanup job delegated by the Pmon, and it periodically performs the cleanup of terminated sessions, transactions, idle sessions, etc., etc. So again, this cleanup main process is like a supervisor. So the actual work will be done by this cleanup helper process. So this will be actually doing the work on, and the cleanup main process will be just looking at supervising the activity. And if you remember, we have one responsibility for PMON, that is registering the listener information with the instance. Now that responsibility has been taken over from PMON, and Oracle has introduced one new background process called listener registration process, LREG, and this process is responsible now for registering the listener information with the Oracle instance. So because we have not seen much about a listener, really you may not understand this point, what exactly you mean by registering with listener or registering with instance. So when we deal with networking with Oracle, I will tell you about that. I will show you how that listener registration will be done. And also this PMON, cleanup main process and cleanup helper process. Together now we are calling it as PMON group. So that is about the new background process what we have. Then we have a new concept called full database caching. So it is self-explainable, very easy. So if your database size is small and if your RAM size is more, then Oracle provides you an option to keep entire database in the memory itself. Let's say you have 64 GB RAM and your database size is 10 GB. Obviously, you can fit 10 GB database into 64 GB RAM. So if you place entire 10 GB database into your RAM, that is into your buffer cache, then obviously you don't need to perform an IO at all. Because if all the data is there in the memory itself, why you will go to disk? So that is a concept here. Because the RAM size are becoming very much cheaper, so nowadays it is possible that you can have your entire database, and this applicable only for smaller databases obviously. So this is what it is saying. Starting from Oracle 12c release 1, Oracle provided us the option to keep entire database in the buffer cache, and to improve the performance basically. So by default this is not enabled, but you can enable it on by issuing some commands. So the commands are this. So first you need to place the database in mount state. Or well, before going further, if you want to see whether it is enabled or not, we have a query like this. So if it is not enabled, we can enable it with the help of these steps. First we need to say mount, then we need to use this command alter database force full database caching. Then you need to open the database. Similarly, if you want to disable, you need to follow these steps. So that is about the things. So the next part is installing Oracle 12c. So let us go with that. Okay, so here if you see the 7.4 Linux installation got completed, it is asking for reboot. So I'm just doing that. So to do installation in real time, we would be using some tools. So the first tool is of course Putty. So Putty is used to connect to the server and to perform some commands. But Putty cannot be used to copy the software from Windows machine or something. Let's say you have the software on your desktop, which is running on Windows machine. You cannot copy that with the help of putty to the Linux server. So for that we are using a separate software called WinSCP. And also putty cannot invoke graphical interface. So for that we have some either we need to go with some third party tools or some free tools. So we'll be discussing about that as well. So after rebooting your Linux machine, now it is asking for the license acceptance. So just click on that and click on I accept and finish configuration. Okay, so click on next. So location services not required. Okay, take. So here it will ask you to create one user. So you can create one sample user, yeah, even though we don't use that user. So because until unless you create, it won't allow you to go further. That's it. So once we have this, then we are not going to use VMware directly. So instead we'll be always connecting through PuTTY. So let me open PuTTY and show you the things. So this is my PuTTY. So you need to make a note of the IP address what we have given earlier. So I have given this IP 192.168.1.130. So the very first time when you are connecting, it is asking for the secure connection. So click on yes. Then you need to provide the credentials, root and its password. So this is how, every time when you start your Linux machine in VMware, so you would be connecting. So don't directly run the commands. So because in real time we don't do that, we always use PuTTY because the servers will be there in remote locations. So let's start with the installation process. So there is one text pad attached or text file attached to your document. So if you open that text file, it will show you the steps on how we need to proceed with the 12c installation. So there are many steps that we need to do. So we need to follow with those things. So the first thing is, so all these steps you need to do as a root user only. So now coming to how it will be done in real time, because in real time you may not have access as a root user to the database servers. So only Linux administrators or Unix administrators will be having access. So how it happens in real time is in two ways. One is you give all these steps to the Unix administrator and they will execute on behalf of you. So you need to guide them how they need to execute and all. That is one way. And number two, temporarily they will provide you the root access. So especially when you are doing this installation means most of the times you will be doing it on a fresh server. So temporarily your Unix administrators will give the root access to you. So then you can go ahead and you can do the steps on your own. So there are two ways. So it depends on the project. It depends on the policy in the project, how it is defined. They will follow it. So if it comes to you, then it is good, or otherwise, you need to provide the steps to them. So initially, we are going to add some groups here. So we need to copy and paste. So first command is group add o install. So we are going to create a group over here by the name o install, which means, so when I say group, obviously tomorrow I will be adding a user to this group. So when I add a user to this group, it means that that user can perform any Oracle installation on this particular server. Suppose I added a user Pawan to this install group. Then it means that Pawan user will be able to do Oracle installation. So either it could be a 10G version or 11G version or 12C version. So Oracle Pawan user will be able to do that thing. So that is the meaning of adding this particular group. Similarly, we have another group called DBA. So here also, if I add some XYZ to user to this DBA group, it means that that user can perform all the database administration activities like starting and shutting down the database, then creating the users, creating the table spaces, etc. etc. So whoever is part of that group, they can be able to do uh, the database administration. So earlier we used to have two separate users, like one user to do the Oracle installation and one user to do the database administration. But over a period of time, many people felt like it is really not required to have two separate users to do that. So that is why they have only one user now. Like generally in real time nowadays we are following only one user. So we are creating that user with the help of this command user add, and we are going to specify. So the point here is the same user wants to do Oracle installation and the same user want to do Oracle database administration. So that is the reason we are going to say oinstall as the primary group. So when you say hyphen small g, it means that it is the primary group. So oinstall is the primary group and dba is the secondary group. It means that this user is part of both the groups. So which means that user can do Oracle installation as well as DB administration. And what is the username? So generally we follow the username as Oracle, or some people or in some projects you will be seeing this name as with the version. For example, if I am installing Oracle 12c, they will give it as Oracle 12, or if you are doing 11G installation, they will go with Oracle 11, or most of the times it will be only Oracle. If you want, you can give your name as well. There is nothing wrong. But some standard we are following. So that's the reason we are going with the name as Oracle. So now if you type ID Oracle, you can see this Oracle is part of oinstall group as well as the DBA group. So that is the meaning of this user add command. Then we are going to change the password of that Oracle user, because we just added the user but we have not specified any password. So you can give some password. Then we have created these mount points U01, U02 and U03. By default, root user will be having the access on these mount points. So we are changing the ownership of those mount points to Oracle user. because going forward we'll be using those mount points or as Oracle user. So we are just changing the ownership with the help of this chown command. So those are the initial steps that we need to do. So any questions over here? Okay. So the next thing is, in this particular file etc host, we need to add the IP address and the host name of our machine. So just like an example here you can see. So let me open this with VA editor, and you can see there is no line with the IP address of the machine. So I am giving it 192.168.1.130, and then I need to give my host name. So host name is 12c server. You need to press a tab. So and then you need to provide your host name here. Then save this file. Then you need to cross check whether the host name is correct in this particular file etc host name. So here and here it should show same value. Then the important thing is kernel parameters. So what are these kernel parameters? So we are going to specify how much memory Oracle can use, and minimum how much it can use, maximum how much it can use, what is the network ports that Oracle can use, how many files Oracle can create, so and something about semaphores. So all these things will be declared in this. For example here, how many files can Oracle create? So somewhere we have very huge value here. Similarly, how much maximum memory that Oracle can use, or how much minimum memory Oracle can use, or what are the network ports that Oracle can use. So all these will be called as kernel parameters. So there are some standard values for each and every version. So you can these are the default values, minimum values what we require. So if really you, I mean to say, like if you got into some issues, then you can go ahead and change the values of this. Most of the times you will be changing the value of this shared memory maximum. Rest all other parameters, usually you don't touch them, because no, there will be no chance that you will be going ahead and increasing the value of them. So these kernel parameters will be residing in this particular file etc sysctl.conf. So you need to just open a new line and copy and paste. So once you copy and paste, save them. Then to make immediate effect, so if you want these kernel parameters to take immediate effect, we need to run this command sysctl-p. Then immediately these parameters will come into picture. Then we have some other file where we need to go ahead and include some lines. So these are all OS level settings that Oracle recommends to do. So in order to successfully install our Oracle software. Then another file, and we need to add a line here. So this particular thing we need to copy, then come back to the file and go to last and paste it. So always make sure you are saving the file properly, so otherwise it would be a problem. So now comes the important step, that is installing the extra packages. So even though we have installed a full version of Oracle Linux, still it requires some packages to be downloaded and it need to be installed. So for that we are going to have two things. One is your Linux machine should be connected to the internet. So one advantage is because we are using the similar IP address as Windows machine. So obviously by default this Linux machine will be connected to internet just like your Windows machine. But in case if it is not connected, then you need to manually download all these packages from Google and you need to copy them, then you need to install them. That is, again a tedious process. But if you follow the way how I showed, like bridged connection, then choosing the correct IP address and all, then you don't face any issues. So we need to run a command yum install. Yum is the command to do the installation of these packages. So before going for that, sometimes there will be already one yum process running. So to make sure whether it is running or not, we just issue a command ps-ef grep yum. If you are not seeing any values over here, so this one you can ignore. That is the same command what we have issued. So apart from this, if you see some other process is there, you need to kill that process. Suppose you see some process with ID, so this is the process ID. You need to say kill -9 and then that particular process ID. But if you don't see anything, then it is fine. You can directly start your installation. So what you need to do is just copy all these commands and paste it here. Just a moment. Okay, so here it seems that it has not connected to the internet. So here if you look at the message at last, it is saying that it will basically try to connect to this, but it seems that it is not able to connect to that internet. So if it is not not connecting to internet, this is what will happen. So you'll be receiving the error. Let me try. Okay, so even okay, so I'm able to ping from Windows to Linux, but not in reverse way. So let me try a reboot. So I'm just trying for a reboot. So let us see after that whether it will come up or not. Okay, so anyway, like even we have done with the time also. Fine. So tomorrow we will continue from this step. So we will go with this M installation and further steps, and then we will see the installation process. So anyone having any questions before we close the session for today?
Hi, Pawan. Is this standard for all installation?
It is only for 12C release 2.
I'm asking about the count. I mean, the numbering,
Uh,
memory structure. Go to this, I think, sixth step.
okay, in kernel
No,
parameter.
no, fourth step, I think. This one, yes.
Yeah, this one it varies again with the version. Like for 11G,
Okay,
the values will be different, and for 12C, the values will be different. I will share you the document for 11G as well.
okay, okay. Thank you.
Okay, so then let's meet tomorrow at the same time, and we'll continue with the things. So thanks everyone for joining. Have a nice day.
Thanks, Paul.